Okay, I've been working on this finding out where you are problem, and this is what I have so far. I'm not sure this is the direction I want to go, so I kind of stopped, but I can finish it the 100% of the way if you want. Okay, so I just want to give you a little brief overview. So my idea is that here's some sound source and here's another sound source, and they're at some known locations, and we're trying to find the location where you would hear it. And if they both make a sound, you will hear a difference in the sounds based on where you're at. That's the basic idea. So I have here the velocity of sound. It's 340 meters per second, but I know no one likes metric because metric's evil for some reason. I don't know why. So 0.211 miles per second might be a good thing to use too. So if that's the case, when you make a sound, it spreads out in a circle. I can find the radius of that circle just based on the definition of constant velocity. So the radius of circle A for object A, this one's A and that one's B, would just be the velocity of sound times the time it travels, which we don't know because we don't know how far we are. And the same thing for B. But what I'm imagining is that he hears sound A and then sound B, and it's like 2 seconds apart. I just picked 2 seconds. I don't know. We can do it with any numbers you want. So I can solve for this equation, I solve for TA, solve that one for TB, and take the difference, and then I can solve for the difference in distances. Okay, so I know that, and I actually use the numbers. So RB minus RA is 0.422 miles. So that's the difference in distances. Now, if you're right here and right there, these two make these radiuses circles, but you don't know actually where you are. And I can actually get you this location, these two locations, based on this distance and that distance. See, it changes as you move along these circles. So you can actually find out you're either here or you're there. They have the same solutions. So that is how we're going to do it. And then you can pick the direction based on saying, okay, the sewer water flows west to the ocean. So that way I know we can pick the direction somehow that way. But this is what I have so far. I just wanted to explain it because I think it'd be easier than typing it up in an email. Okay, I'm in the airport. Okay, I hope you can hear me. Okay, so I made it a little bit simpler. So here we have a velocity of 6,000 meters per second. That's 3.37 miles per second. You can convert that. The time difference between the two signals is 2 seconds. So in that 2 seconds, one thing goes faster than the other. So here I can calculate based on the speed of sound, is distance over the change in time. Solve for S. That's 7.44. That's how much further it has to. One of them has to go. So now I have my two locations, and I draw a circle, and this distance has to be 7.44 miles. So once you do that, then you get two locations, here and there. Those are the two parts that he could be.